Hello, welcome to video 3 of 9 for Chapter 1 of Basic Sentential Logic, Informal Fallacies, and Cognitive Biases. In this video, I'm basically going to be talking about Section 1.2.1. The topic more or less corresponds to that section in the textbook. Topic is the distinction between atomic and compound statements, a rough idea of what statement operators are, and then discussion of recursion. So, as we discussed already, an argument has to have a form. We're interested in the form of an argument, okay? And an argument is a set of statements, right? We talked about that in a previous video. There's some statements corresponding to the premises and some that correspond to the conclusion. What this means is that an argument's logical form is more or less almost completely determined by the form of the premises and the conclusion, those statements that make it up, okay? And a statement's form, okay, is going to be determined by the atomic statements that it's composed of and the statement operators that are used to build up the compound statement, if it is compound, from the atomic statements. This may not have made a whole lot of sense, but it will shortly. The basic idea is we want to know what an argument's form is to be able to assess validity. An argument is a set of statements, so that means the first thing we need to do is figure out how to understand a statement's form, the form of a given statement. And this distinction between atomic, compound statements and operators is basically how we're going to get at that form. And that's what I'm going to be explaining right now. The first thing is this distinction, a distinction between kinds of statements, atomic and compound statements. So what is a statement? A statement is something that makes a claim. Okay, it can be expressed with a sentence. It's not a question, it's not an exclamation. And statements are going to be the premises and the conclusion of arguments. Now, what's an atomic statement? Atomic statement is going to be a statement that does not have parts that are themselves statements, whereas a compound statement is a statement that does have parts which are themselves statements. And we've already seen some examples of this. This is the rabbit argument. It's the same form as the pizza argument, either X or Y, not Y, therefore X. In this case, it's either the rabbit ran down the left trail or the rabbit ran down the right trail. It's false that the rabbit ran down the right trail, therefore the rabbit ran down the left trail. Now, let's look at premise 1. Either the rabbit ran down the left trail or the rabbit ran down the right trail. I've underlined two parts of this. And you'll notice that the two parts I've underlined are themselves statements. The rabbit ran down the left trail. That by itself is a statement. That could be true or false. The second thing I underlined, the rabbit ran down the right trail, that is also a statement. So premise 1 is a compound statement. It has parts which are themselves statements, okay? And they're sort of put together with this either or. We'll talk about this in a minute, but this is an operator. Let's look at premise 2. It's false that the rabbit ran down the right trail. Well, it has as a part the rabbit ran down the right trail. Okay? This other thing is this, it is false that. That's another operator. Okay? That's going to turn an atomic statement into a compound statement. So 2 is compound, and this part of 2, the rabbit ran down the right trail, is atomic. The conclusion, that's just an atomic statement. The rabbit ran down the left trail. Now what's interesting is that this whole argument only uses 2 atomic statements. I've sort of color-coded them red and blue here. The first premise puts those 2 atomic statements kind of together with an either or. The second one puts the blue atomic statement kind of together with this, it is false that, this operator. And the conclusion is just the red atomic statement by itself. Okay. So compound statements are built up from atomic statements. Think of atomic statements as like bricks, and compound statements as like things you built with a brick, or one or more bricks. And they're these statement operators that are used to build up the atomic statements. We've seen two, either something or something. We've also seen it is false that. Okay, and we've seen them both here in this sentence. Either this or that, it is false that this, therefore that. Okay. So now what I want to do is to talk about these operators. You understand now the distinction between atomic and compound. That distinction hinges on these operators, because the operators are the things that put together compound statements. So let's take a closer look at these operators, and then also the topic of recursion, and I'll get to what that means. Altogether, we're going to get 4 operators in the text, in the normal material. There's a 5th operator in the optional material, but I'm not going to talk about that in the videos. The 4 operators as part of the normal material is negation, which is expressed in English in a number of ways. We're going to look through at all 4 of these in more detail, but just quickly, negation is usually expressed by it is false that, or sometimes N''T on the verb of the sentence. Conjunction, expressed with and, but there's a few other ways to express it. We'll see in the next video. Disjunction, or, either or, unless, as we'll see, those are ways of expressing disjunction. Conditional, if something, then something. These 4 operators govern most of what's going on in normal English reasoning and talking. The biconditional, which is the 5th one that's in the optional material, really doesn't show up too often with normal people. Math majors, computer science majors, philosophers will use biconditional, but for the most part, these 4 are the key. Now let's see how these operators work. Here's 2 atomic statements. John is at the party, there is pizza at the party. And we can use the operators to make compound statements if we apply those operators to one or more of these atomic statements. So for instance, I could say John isn't at the party. That's a compound statement. It's the atomic statement, John is at the party, but with the negation operator added to it. And it gets John isn't at the party in English. I could use conjunction. I could say there is pizza at the party and John is at the party. I could use disjunction. Either there is pizza at the party or either John is at the party or there is pizza at the party. I could use conditional. If there is pizza at the party, then John is at the party. Notice that, especially if you look at the last 3, because conjunction, disjunction, and conditional are all 2-place operators. They put together 2 statements into a compound statement. They all use the same 2 atomic statements, but they all mean different things. So the difference of meaning isn't because they're using different atomic statements. The difference of meaning is because of these operators. In chapter 2, we're going to look at exactly what these operators mean. For now, we just want to translate them into the formal notation. Before we start doing that, though, I want to point out one crucial thing about these operators, which is recursion. These 4 statement operators are recursive, meaning that they can take as input, or they can operate on, not only atomic statements to make compound statements, but they can also operate on their own outputs, meaning that they can also operate on a compound statement to make an even bigger compound statement. And then another operator can operate on that to make an even bigger compound statement. And you can do that to make things arbitrarily complex. Now, you're all familiar with this. Actually, you're familiar with this in 2 ways. You're familiar with it because everyone watching this video makes and speaks and understands statements with recursive structure all the time. Okay, you guys maybe haven't thought about it in that way, but ever since you've learned to talk, you've learned to put together statements that have multiple levels of recursion and operators. So in that sense, you're familiar with this implicitly. Most of you haven't explicitly thought about it or been exposed to that fact, but there's another sense in which you are explicitly familiar with recursion, which is in arithmetic. So what I'm going to do is I'm going to talk about arithmetic operators for a minute, because statement operators work in the same way in terms of their recursion. And so by kind of reminding you of what you know about arithmetic operators, that will shed light on how the statement operators work. Well, the big four arithmetic operators are addition, subtraction, multiplication, and division. And the atomic entities, so to speak, that these operators work on are numerals. And these are like 5 and 3 and whatever. And you can use operators to put together compound arithmetic expressions. So I can use the addition operator to put together 5 plus 3 to make the compound expression 5 plus 3. I could use different operators with the same atomic expressions, 5 times 3, 5 minus 3, 5 divided by 3, and so on. But the arithmetic operators that are recursive, meaning that not only they're not limited to putting together atomic elements into a bigger compound element, they can also operate on things that are already compound to make an even bigger compound statement. So for example, I can go 5 plus 3, addition operator, operating on two things that are themselves atomic. But then this thing that was produced by the addition operator, this thing itself can now be input to the addition operator again. And I can have 5 plus 3 plus 4 times 9. And then this whole thing can be input to that operator again, like this. The other input is 3 minus 1, this thing that was itself constructed by an operator. Okay, so this is recursion. This is where these operators can not only operate on the atomic things, they can also operate on compound things, the things they themselves have built to make even bigger compound statements. Statement operators work in the same way. So I'll show you some examples. Here's 4 atomic statements. You pay me the $20 you owe me. You come to the party. I'll jack your ride. I'll steal your wallet. So those are 4 atomic statements. Now we can start putting these together with statement operators. I can say, if you come to the party, then I'll steal your wallet. And you all know what this means. Not that you guys go around stealing wallets, but you could produce a sentence like this with if then. So you guys all can use statement operators, and you have been able to do that since you could speak. But I could also put together a statement like this. If you come to the party and you don't pay me the $20 you owe me, then either I'll steal your wallet or I'll jack your ride. Now let's take a look at this, because this is a compound statement. It's an if-then, if something, if blue, then yellow. So I've coded the blue statement and the yellow statement as the two components that are put together with this if-then. But notice that these components are themselves compound. You come to the party and you don't pay me the $20 you owe me. Let's focus on that. I'm going to gray the rest out. That itself is a compound statement. It's this and this green part here. Okay, and in fact the green part is also compound. It's got a negation operator in here. So this has 3 layers of recursion, so to speak. One thing I want to emphasize before we move on is that you might look at this, the word recursion and operators, and think, okay, this is a bunch of fancy stuff that logicians have invented and now they want me to memorize this or whatever. And in one sense, that's right. But in another sense, this is stuff you already know. Everyone watching this video can understand, not only understand sentences like this, but can produce sentences like this. Okay, often you will use, very complicated sentences to express things to people about what you're ordering or the conditions under which you'll do this or that. Okay, so ever since you could speak, since you've 2 or 3 years old, where you've been able to put together statements with multiple levels of recursion like this. So implicitly, this is stuff you already know how to do. What we're doing right now is we're learning some terminology and getting some symbols to help you understand this thing that you've been able to do most of your life. Okay, so try to frame it in that way. This isn't like some new stuff that you're being forced to learn that really doesn't have application. This is you learning something about yourself, learning to understand something that you've been able to do for a long time, but haven't really thought about it probably. Okay, that's it for now. Next, we're going to move on to the 4 operators in detail. Conjunction, negation, disjunction, and conditional. Those will be the next videos.